Hey guys, how you doing? So in this video I'm going to discuss DHCP. First I'm going to explain a little bit about DHCP and then we will see in a Wireshark capture that how DHCP works. So to start with, first I would like to tell you that DHCP is nothing but it stands for Dynamic Host Configuration Protocol. DHCP provides a framework to configure hosts with information required to communicate on a network. So the host could be your laptop, could be your computer, could be a server, or could be any computing or networking device on a network. Now the information that is configured using DHCP is an IP address, a subnet mask, DNS, gateway, and some other information that will be required for a device to communicate and pass some information on a network. So let us just start with the DORA process. That is an important concept in the DHCP. So whenever you go for an interview or you're writing an exam, you will always be asked about the DORA process. And if you're able to explain the DORA process properly, then you've done a good job. So the DORA process, as the name says, starts with the letter D. So let me grab my pen and explain you a little bit about how the DORA process works. So this is basically an acronym. The D here stands for discover, O stands for offer, R stands for request, and E stands for acknowledge. So let us break each of these letters part by part and understand what role is played by each of these packets. So when a client on a network boots up and requests or wants to get the network information from a then the client will send a discover packet. So this is your client, and this client will send a discover packet to the DHCP server. So this server is your DHCP server. I'm sorry for this. Yeah. And this message is a broadcast message. This is an important thing to remember here, that the client sends a broadcast to the server, or basically broadcast on a network, and the server will respond to that broadcast message with an offer. Now, this offer message will contain a valid IP address detail that the server wants the client to accept. Now, the client will send a request if the client finds the offered network information suitable. So this message that the server sends, the offer message, is a unicast. And the third message that we just discussed, the request message, this one, this is again a broadcast. Now you'll wonder why this message is broadcast. I'll tell you the reason when we see the Wireshark capture. Now the last message that is sent by the server to the client is a unicast message, and that message is an acknowledgement of the server. And so the acknowledgement message basically is sent by the server to tell the client that yes, you can go ahead and start using that network information to communicate on the network. Alright, so this was just a high level theory about DHCP. Now we'll just go into the Wireshark capture, because the motto of the video is to understand and learn how we can capture a DHCP handshake and how we can see the packets exchanged in a DHCP process in a Wireshark tool. So I'm going to delete this. Okay. Alright, so as you can see here in this video, I have opened the Wireshark tool and added a filter of boot P. So the reason I've added a filter with the name bootp is because DHCP essentially works on the bootstrap protocol, and that is why we have to use bootp instead of DHCP to filter all the DHCP packets. Alright, so let us get started. First I'm going to start this capture, and just give me a moment here, guys. Okay, let me do one thing. I'm going to release my IP address so that the laptop that I'm using will request for a new IP address from the DHCP server, and the DHCP server in my case is going to be the Wi-Fi router that I'm connected to. So the first step in this process would be to release my existing IP address. Alright, I've done that, and that says DHCP release. Yep, so the first packet that the Wireshark tool has captured is the DHCP release packet. And what we need to understand here is that this DHCP release packet was sent from my laptop because I entered a command ipconfig release, and this message was sent to the Cisco Wi-Fi router that I'm connected with. And another important information about DHCP that you should remember is that the client port in case of a DHCP communication is 68, and the destination port, that is the server port, would be 67. So we can see here the destination port here is 67 and the source port, that is the client's port, is 68. Alright, so this was a unicast message from the client because the client was going to send or to inform the server that it's no longer going to use the assigned IP address, and it has released the assigned IP address. And you can now see some more information in the bootstrap protocol section or the header of the release packet. So you can see the client IP address that was assigned or being used by my laptop is this, and client MAC address is also shown here. Now something important to note here is that this packet, that the type of packet that this is visible under the option 53 section. So if this was some other message or some other type of packet, we will see that in the option 53. And the option 54 is basically a DHCP server identifier. So if you want to know, if you know the IP address of your server and you want to add that in your server identifier, then you use this option 54 field to add that information. Similarly, there is a client identifier. Alright, so there's nothing much in the Bootstrap protocol header section of this packet because we haven't done much here. The only thing that we should take from this particular packet is that the option 53 of this packet says DHCP release, and this is sent from the client to the server. Okay guys, now let's move on to the interesting stuff. We're going to release, we have just released the IP address. Now we are going to ask the DHCP server for a new set of IP address configuration. For that, I'm going to run ipconfig/renew. Let us see how this works, or how this is shown in the Wireshark tool. So I'll do renew, and what I got here, guys, is the DORA process. So the DORA process got completed, the same thing that we discussed in our notes a couple of minutes back. The discover packet is sent from the client to the network because it's a broadcast packet. And as we discussed earlier, the client port is 68, the destination port of the server will be 67, and it's a Bootstrap protocol. And you can see the type of message is a discover. So option 53 will always inform you about the type of message that you are sending. And the client identifier has the MAC address of the client. And one important thing here is now we can see the option 50. What that means is there is a particular IP address that the client has requested for. So the client was earlier configured with the same IP address, and when we did a request for a new set of IP address, the client itself has asked for the same set of IP address to be assigned by the server. So if the server has this IP address available in its database, it will assign the client the same server because the client has specifically requested using option 50 that it wants this IP address. So the host name of the client is also sent in the DHCP discover packet. Alright, so that's a lot of other control information that at the moment you need not be aware of. Now we can go ahead and see the second packet. So if you remember guys, I told you the second packet is basically a unicast packet that's sent from the server. So this is my server's IP address to the client. So you can see the server is the source and the destination is my laptop, and it's basically sending this information to the IP address. And again, you can see this says option 53, that is your DHCP offer. And there's a server identifier, and here you go. You get the option 51 as your IP address, you get the option 1 as your subnet mask, you get the option 3 as your router, that's the default gateway, and in option 6 you get the domain name server. Also the option 15 has the domain name, so there's a domain name IP address and there's a domain name prefix, or the domain name essentially, that is configured to the client, that's given in the option number 15. And guys, one more important thing you need to know is what's the lease time. So the lease time for this client or for this IP assignment is 1 hour. So my client will request for a new set of IP address, or basically will renew the IP address IP config after 3600 seconds. That's 1 hour. Alright, next let's move to the next packet, that is the DHCP request packet. So what does a request packet do? It's basically sent from the client to the server, and the client will request for a set of IP addresses that it decides based on the offer given by the server. So let us see what the client has requested for. There you go. The client has requested for the same IP address, that's 10.200.178.226 that was being used by the client before. So nothing new at the moment. Again, the server identifier, the host name is also there as option 12. There is a client fully qualified domain name and a bunch of other information that we don't have to really care about at the moment. Alright, so one important thing to note here is that this message is again a broadcast. So if you remember, the first message, that's the DHCP discover, is going to be a broadcast. The second message that's sent from the server to the client is going to be a unicast. And the third message that we are looking at right now, a request message, is also going to be a broadcast. So anything that's sent from the client to the server is going to be a broadcast. And an important reason that, I told you that, I'll tell you the reason when we see the capture. The reason it is broadcast is because there could be multiple DHCP servers on a network. And that is the reason client will always send a broadcast to the server, and the server knows there's only one client that's requesting for that set of information or sending that particular packet, and so the server will always try to keep the message as a unicast. Alright, so let us go to the last packet. In the last packet you can see the packet is a DHCP acknowledgement that's sent from the DHCP server, which is the Wi-Fi router in our case, to the client. So this particular message is going to be a unicast, as you can see from this message. It's directed to a particular destination that's not a broadcast destination. And if you look at this information here, the DHCP server has acknowledged all this information. This message type is an ACK, and the ACK is given for this set of information. So basically what it means is that the server says to the client that okay, you can go ahead and start using all this information to communicate on the network. All right, so this is pretty much about the DHCP process, DORA process, and yeah, stay tuned for my other videos. I'm going to focus a lot on the Wireshark capture for every network technology, every network protocol. So probably I'm going to do an IPsec VPN video in the next one. So stay tuned. Thank you for watching. Have a good day.